All right, example 1 took quite a long time, and as I said, these are not short problems, so I do apologize. We'll see if we can get these last 2 done, but I'm not counting on it, not in one video anyway. All right, we want to find the surface area of a cylinder. Again, this is something that we should be able to figure out regardless, but we're going to do it parameterized just to make sure you can see it. So a cylinder, let's go ahead and sketch a cylinder. See if I can not run out of space here. So a cylinder has a height, and it's got a radius, and we know how to find the volume of a cylinder, but we're only trying to find the surface area. So the surface area of a cylinder is going to consist of the bottom and the top of the cylinder, which is really just a disc, and then the lateral face of the cylinder. So when we do this, we actually have to do separate surface areas to be able to figure this out. So let's go ahead and do the bottom or the top. Either one should pretty much be the same thing. Let's see. X is going to be, it's circular, so we're going to go ahead and parameterize these in polar. X is going to be r cosine theta, y is going to be r sine theta, and if it's the bottom, z would be 0, and if it's the top, z is going to be whatever the height of that is. So we're just going to say in this case that z is z. Actually, no, z is 0 and z is h, whatever the height is. Yeah, that's what I said the first time. So if it's the top, z is 0. I'm sorry, if z is... Let me start over again. If it's the bottom, z is 0. If it's the top, z is h. So we're going to go ahead and parameterize this. Now remember that those are constants. 0 and h are constants, so they are not going to affect anything. Let's go ahead and write out r, and it's going to be r of, it's going to be weird, r and theta. The two r's stand for different things. The outside r means it's the vector function, and the inside r means it's the radius. Okay, so we're going to need r cosine theta, r sine theta, and regardless of whether it's the bottom or the top, it's going to be some kind of a constant. So I'm just going to put a constant c in there. Let's go ahead and make sure we state that r is going to go from 0 to a, and theta is going to go from 0 to 2 pi. Okay, what we need is we need r sub r. We need the partial of this thing with respect to r. So the partial of the r function with respect to r is going to be cosine theta, sine theta, 0. We're going to need the partial of r with respect to theta. The partial of r with respect to theta is going to be negative r sine theta. The partial of r sine theta is going to be r cosine theta, and then a constant again is 0. So if we take the cross product, this one is actually quite nice. If I eliminate the I row and column, I get 0 minus 0. Well, that's 0. If I eliminate the j row and column, I get 0 minus 0. That's still 0. So really the only thing that gives us anything is the k part. Eliminating the k row and column, I'm going to get r cosine squared theta minus a minus or plus r sine squared theta. And you should recognize r cosine squared plus r sine squared, factoring out the r, as just r, because cosine squared plus sine squared is 1. So we're just going to get r. So really what this gives us is 0, 0, r. So the magnitude of r sub r cross r sub theta is each one of those pieces squared. Well, 0 squared plus 0 squared plus r squared, take the square root of that and you just get r. I did not write that one out. Hopefully you guys can see that one. Okay, so let's go ahead and find the surface areas. So the surface area of these things, again, surface area is defined to be, let's see, 0 to 2 pi, 0 to a for r, and then it's r dr d theta. That should look familiar as well. That r is the conversion factor into cylindrical, and that's exactly what we've done here, is cylindrical. So let's go ahead and figure this out real quick. 0 to 2 pi of d theta times 0 to a of r dr is going to be 2 pi times 1/2 r squared from 0 to a. The 2 and the 1/2 are going to go away, so we're going to get a squared pi, or pi a squared. And again, if a is just simply r, you get pi r squared, which of course is the area, surface area of a disk, which is exactly what we have there. And then we'd have two of them, because the bottom is going to be exactly the same as the top. So we're going to have two of these. So we're going to get 2 pi a squareds out of that. Now let's do the lateral side. So if we do the lateral side, well, let's see. X is going to be, now remember that we are only talking about the outside of the cylinder, so we're not talking about everything on the inside. So X is now going to be defined as a cosine of theta, because this thing has a distance, a maximum r distance of a, and that's at the outside. So it's x equals a sine theta, y equals a cosine theta, then a sine theta for y, and z in this case once again is just going to equal z. But now this is going to be a function of of theta and z. So let's go ahead and write that out. R of theta and z equals a cosine theta, a sine theta, z. Let's take the partials. I'm not sure if you guys can hear that in the background, but we're getting a message from Mr. Orlato. Hopefully it's not too clear to you guys, but anyway, we're going to push on. R sub theta, the partial of this thing with respect to theta, is negative a sine theta, a cosine theta, and then 0, because z has no thetas in it. And then r sub z, this is going to be the easier one, 0, 0, 1. Alright, so now we're going to take the cross product, r sub theta cross r sub z. So if I eliminate the I row and I column, I'm going to get a cosine theta. If I eliminate the j row and column, I am going to get negative a sine theta, but we have to make that positive. We have to change the sign. And then if we eliminate the k row and column, we are going to get 0. 0 minus 0 is 0. Okay, so now we need to take the magnitude. So it's going to be the square root of a squared cosine squared theta plus a squared sine squared theta plus 0. So really that's just going to be, if I factor the a's out, I'll have a times the square root of cosine squared plus sine squared, but that's 1. So it's just going to be a. So now let's go ahead and find the surface area for the lateral surface area. Theta goes from 0 to 2 pi. Z goes from 0 to h, whatever the height is, of a dz d theta. So let's go ahead and separate these things. 0 to 2 pi of d theta. We can pull the a out to the front, times 0 to h dz. So we're going to get a times 2 pi times h. So we get 2 pi ah, which again, if you were to take that cylinder and open it up, it would basically be, this is 2 pi r right there, which is the circumference of the cylinder times the height. So it really is just, it's basically like a rectangle. It's a length times the width of a rectangle if you were to take the cylinder part, the lateral face, and open it up. So the total surface area of this entire thing is 2 pi ah plus 2 pi a squared. Alright, more than likely that has taken way too much time as well, so I'm going to probably have to do the next one in one more video.